Perfect. I can hear you and see you.
All right. How's everyone doing? Thank you for joining us. We're excited to go through all things Tinkercad, Robo 3D, RoboPrint, all the above.
Yeah, so while we were waiting for you to get the technical issues sorted out, we found out I was asking anyone if they have 3D design experience, and we have at least some people who do, who have popped in the chat on that, but I expect we will have a wide range of folks here who both have and have not done any design challenges. So
We need some more participation from the audience, though.
It is
Come on, guys, use that chat box.
All right, I am going to start sharing our screen or sharing my screen and kick things off. Welcome again to everyone officially here for this month's Learning Lab podcast. This one is 3D design for 3D printing, all about tweaking student designs for printing success. And we are going to be talking a little bit about classroom tips, but we're going to spend most of the time in actual ways to use Tinkercad and RoboPrint as free tools to check student designs, have students check each other's designs, and things you can do with your slicer settings and things like that to really just make 3D design more likely to be a success for you as you implement this with your students. We will be keeping the chat open, as Braydon said, so do ask your questions, be part of the conversation. It's more fun for us if we get to talk to you as well as each other. So this month's Learning Lab is brought to you by Mimeo STEM. And we, of course, have a whole slew of educational STEM products from our own Robo 3D printers. That's the RoboPrint free software I mentioned earlier, works with our printers, but can be used to help you troubleshoot your designs no matter what printer you have, as well as our curriculum with engineering design challenges, sensors, professional development, the whole works. So thank you for joining today. And Braydon, why don't you kick us off as the, co-founder of Robo, the mind behind these 3D printers, with some general classroom tips and suggestions for how you can be successful with implementing 3D printing in your classroom environment.
Yeah, of course. Adrian, thanks for responding in the chat box. Appreciate that. I just wanted to see if anyone is using 3D modeling or 3D design with their students. We're going to talk about Tinkercad specifically today, but there's definitely other 3D modeling softwares that can be used or are currently being used by teachers and educators. So don't think you have to use this one, but Tinkercad is very much set up to be a really good teacher tool for doing 3D design with students. Now, once again, Hannah had said I'm one of the co-founders of Robo. I've been doing 3D printing for over 12 years now. So a lot of experience. We work with hundreds and hundreds and hundreds, probably thousands of schools at this point, to help them get set up and running with doing 3D modeling and 3D design. Hannah, do you want me to share are we going to go back and forth with sharing? Or...
Yeah, so when you've got things to show, just share your screen, and otherwise they get to look at our pretty faces.
Okay, because I don't have the slide. Oh, I do have it. Hold on, I was just going to go from the slides that you already had set up, but let me see if I can share it. Can you guys see that?
You are good.
Okay, so Tinkercad, right? What are some of the reasons that we use this as educators? First and foremost, obviously, it's free, which is nice. You don't have to draw into budgets to actually use Tinkercad. It is made by a company called Autodesk, and Autodesk makes multiple versions of 3D design software like Tinkercad. Tinkercad is like the education simple version, free, and then they have other versions that are a lot more complex and paid versions as well. So theoretically, students can start with Tinkercad and kind of grow their 3D design or 3D modeling into future software. Other thing, it has lots of great built-in tutorials, okay? So you can follow along with these built-in tutorials, learn how to use this software really quickly and easily. I promise you, teachers that are in here, educators that are in here, students will pick this up very quickly and start using it very easily. So it is easy to use. It is simple to get set up. It's got fun shapes that you can see in the image right there. So you can drag shapes onto the platform and start manipulating them in order to build your first 3D model, okay? If you've never used Tinkercad, go dive in there, make an account, start having fun playing with the tools that are in there. Like I said, there's shapes. You can do text-based models on there as well. So it's really fun and really simple to start using it. I promise you, all of you can become 3D designers in a quick, real simple format. Okay. The other thing we really like about it is that you can develop, as a teacher, you can develop a Tinkercad classroom. Okay. So this is going to allow you to add all your students to the Tinkercad classroom, and it's going to allow you to monitor the things that they're actually designing in there, right? We know some students might not be designing the most appropriate things, so you can tell them to either stop that, you can delete their design. So you have full control over the Tinkercad classroom and all the student designs that are in there, okay? So that is a really great feature, and you can do it without student accounts. They can just click a link, type their name in, and join the classroom that way. Hannah, anything else you want to share on the Tinkercad classroom? Yeah.
Yeah, one of the things I really love about Tinkercad Classroom, and Jillian and I did do a whole intro to Tinkercad podcast like 2 months ago. So that, as well as a whole bunch of Tinkercad tutorials, are on our MimioSTEM YouTube. I just dropped that link in the chat. But some of the other cool things about the classrooms is you can set up specific activities, so you can organize any individual design challenge into that specific activity. You can add comments and not just see your students' design, but also add comments to them, suggestions, things like we're going to show you today, like, hey, fix this. You can do all of that right in Tinkercad. I also wanted to shout out, we have Elizabeth and Sherry both say they're starting to do some 3D design with game pieces and so forth, and that Elizabeth did love the Tinkercad tutorial. So, right from the trenches, our teachers saying that they are loving and using it too. Phyllis is saying she's got Tinkercad classes set up. So this is awesome. Yeah, definitely like the industry standard, I would say, for sure.
Yeah, I agree. Yeah, get in there, start using it. If you don't have it, it's really simple to set up an account. We hear a lot of times from teachers, I don't know where to start with this 3D printer. What do I do with my students? Just get an account in Tinkercad, start messing around with it personally. Once you kind of get a feel for it, you can start building the classroom and all that stuff. Not only in Tinkercad can you do just 3D modeling, but you can also do like something called code blocks, so you can code to 3D model as well. So there's some really cool kind of features and functions built into Tinkercad. All right,
and that code blocks is just like Scratch or Blockly. So if you're doing either of those types of code, either with our, Explorers has a Blockly, our old robots used to have a Blockly environment, same type of code interface. So really easy to adapt for that as well. And they have circuits, which I haven't explored much, but that's a different type of 3D, or not really same 3D design, just another tool.
And just two like simple tricks when you're doing Tinkercad classrooms with your students. The first one is to develop naming conventions for 3D models. Okay, so you're going to have a bunch of students designing all sorts of stuff in your classroom. You're going to see them all on your screen, like all these student designs. So what you want them to do is once they build their design, go up there, you can change the name of the actual model that you're creating. So have them put their name, have them put like what they're creating, and have them put what part of the process they're in, right? That way, if you're the one as the teacher managing the 3D printer in the classroom, you're not letting the students go and print a bunch of stuff all the time, then when it's time for you to go look at the model and determine whether it's ready to be printed or not, okay? So these are just simple ones that I put here. You can do whatever, you fancy in terms of naming conventions, but this is one simple way to do that. And then the other thing.
There are also standards on naming conventions, like in the computer science standards, depending on what state you're in. So you're hitting standards too. Yeah. But beyond that, when you download the files from Tinkercad, they get downloaded with whatever name the students have named them.
Yes.
Naming conventions are very important.
And they'll auto put funny names on there. So yeah, you want students to, before they even start touching the workspace and building a model, you want them to name first. Start the workspace, name, and then go into the modeling. Okay, so that's just one important feature. The other thing is, I hear a lot of the times, like, even though our new E4 3D printer is very fast and you can print a lot more models than we could with our previous model, I hear a lot of times, like, I can't print 30 students' designs or 25 students' designs every single time I do a design challenge. Do not do that. Put them into groups. I call them pods. You can call them whatever you want, but print pods. Put them all into groups. Have them all design. So have them go into Tinkercad and actually build models. And then in each group, maybe they can either vote on which design they want to move forward with for whatever the project is, or the student, you can just go like one by one and only print one design from each pod. Now, once you print that one design, you can kind of cross them off and move on to the next student. That way, each student over a 5 design period will get to print their model. But you're not responsible for printing 25 student models at a time. Okay. So this is just a simple way to sort of do classroom management with 3D design. Still have all the students doing the actual physical design, which is the skill set we want them to acquire, but not making the printing side of it so burdensome for the classroom. Okay. Hannah, you want anything to add there?
No, I think you really hit it on the head. When you look at the design challenges within my STEM kits, we will often suggest different tips. This is one of them. Or like you said, voting. We have one design challenge where students build solitary bee houses, and the houses are huge. They're, roughly the size of your head. So you're probably only printing a single design for the whole class. So in that one, we have the students get to print out like little 1-inch versions of the models, tiny little ones. And then we have little 3D printed bees that every student gets to submit votes for their favorites, and whichever one wins the class vote is the one you get to print. So there are always ways to work around limited print time. And like you said, of course, with the high-speed printers that are out there now, you can do more, but there's often still limitations, especially if you only have a single printer for your classroom.
Yeah, we're going to talk about like being able to print multiple different models onto a platform, things like that. But I think this is a really important piece. And let's face it, STEM is collaborative, and we want students, even young students, working together and kind of, you might have all of them be able to like pitch their model to their group, and then they get to all vote on which model they want to move forward with. So there can be some really fun experiences that can unfold after all the students have designed their models to kind of use some of that collaboration efforts mixed with it. So yeah, these are just a couple of tools and tricks with using Tinkercad. Hannah, I believe I'm going to pass it off to you to show, just kind of learn a little bit more about sort of some of the struggles with using Tinkercad, things to look for if you're an educator and you're going to print an actual model from a student. So I'm gonna pass it off to you. I believe you're going to be showing your screen here. So
yeah.
Sharon.
I also just want to acknowledge Lonnie in the chat. You wanted to know how to set up your Tinkercad classroom. We did do that in our podcast 2 months ago. So I've just put that specific podcast link in the chat for you. We go into lots of good detail on how to set it up, how to set up an activity. So I recommend watching that. But because we do have some folks who are here for that one as well, we don't want to just go all the way back into it. So there are already resources out there for you. Braydon also put the link to Tinkercad classes. It's super intuitive. You just go into the classes menu within your Tinkercad environment. And if you don't see that under your little icon up here, you can adjust your settings to be an educator. But under classes, you just create a new class, add your students, and so forth. So really simple, but I'm not going to go too far into the weeds on that. Thank you for asking, though. We do appreciate the question, and hopefully this much will sort of guide you how to get started. Now, for student designs themselves, I will often get emails from teachers saying, hey, this thing isn't printing. Or we're having all these issues where it's just not printing well. It's not coming out the way it looks fine. I can't see anything wrong with it, but I'm like, hey, send me the STL. Let me take a look at it. And I will oftentimes find easy little tweaks that will make it print more successfully. So I wanted to spend some time today sharing those with you. And so what I've done is actually recreate variations on some of these models I've received from teachers with their students' designs. And I would love for those of you out there who have, especially those of you who have done 3D design and 3D printing, to see if you can spot what I'm looking at when I pull up these models. So like I said, I recreated some similar things to what I've seen in my Tinkercad environment here. So we're going to start with this. All 3 of these models will not print successfully, and they don't look bad at first glance. However, oops, wrong button.
Adrian already picked up on something, snuck in.
Oh, I need to pull my chat back up. The yellow one needs support. Yes. As a general rule, if you are unsure, add support. That is just a good rule of thumb when it comes to 3D printing. Yes. So if you haven't seen a 3D printer in action, now hopefully you all have, it starts at the bottom and works its way up, just like a hot glue gun controlled by a computer. But because it starts at the bottom, anything that is hanging, they're called overhangs, anything that hangs over the edge, like on this model here, her skirt, it's floating, it's up in the air here. It would need support to hold up that skirt. Now, there we go. My screen is just being weird. All right.
And these are things you can obviously, like, once you realize this after you look at a student design, like, you should be talking to the students about this. Like uncovering, because there's a side of 3D design that's just making a model, and then there's a side that's like making it so the 3D printer can print it, you know? So design for a 3D printer, not just 3D design by itself, you know?
Yes. Another comment in the chat was that the green ball doesn't look like it is touching the bottom plate. Now it is, but it isn't doing that very well. So this could cause some weird print issues as well. And yes, the sneaky trophy over here, your chat is on point, is sticking below the rest of this keychain, which is going to cause all sorts of print issues, which unless you start looking closely, and like we encourage you and your students to do, looking at your model from multiple angles, you might very well miss. Now, I have also, one of the other things that I got almost this exact keychain from a teacher at one point. The other thing to notice here is that this ball is very, very flat, which means that we can see all of this good soccer detail in a computer, but when you 3D print this, now the final size of this model is 35 millimeters by 10 millimeters. That is, let me grab a ruler here. That's the long way. That is less than, you know, a couple, I'm having all sorts of issues here. You know, that's less than half of my index finger. This is a very small model. That kind of detail, or even the little detail here on the trophy, where, you know, this isn't necessarily touching the bottom. This is a really thin kind of a, you know, circle point here. When you get to printing really small models, tiny details like this aren't going to show up very well. They might not print because it's so small. So there are actually quite a few little tweaks you could take to this design to make it more successful. So I'm going to first show you a trick in RoboPrint for how you might catch things like this trophy if you didn't catch it by default. And so I am going to name this a file that will make sense when I export it, and do so as an STL, so that'll save to my computer. And then in RoboPrint, if I come to open up from my downloads folder this example keychain, notice I get an informational message when I first bring it in. This model is off the platform. Do you want to put it on the platform? Yeah, that'd be good. I don't want it floating. Repair the model, great, cool. Any of those things it can do, very good. But I'm also now noticing just how small this is. So, you know, maybe you scale it larger, maybe you make sure your students are doing things, and they can go both sides on this, right, Braydon? They can do massive or tiny.
Yeah, we've seen them both. Sometimes they make them way too big. They adjust their settings and make them like as big as the platform, which doesn't necessarily fit the size of the printer platform, or what Hannah's showing here.
Which is, right now I'm pointing out this tiny little blue speck on my screen. This is telling me what is touching the platform right now.
And everyone watching, this is pretty universal. So like if you have any other printers or whatever, you know, if you're looking at the slicing software, like, which is what this is right here, they typically have like a different color when it shows if it's actually flat on the platform or not.
Now that's not true with online, like web-based slicers. Our RoboCloud can't do it, our MyStemKits can't do it, but a lot of the desktop slicers out there have this functionality. So definitely something to look for. One of the other cool things ours has is a feature called Cut. And so when I click on Cut, I can switch the orientation here and just like slide it down to where I can see the full bottom here and just get rid of all of this problematic bottom chunk and then move it back to being on the platform. And now it's a good, clean, flat blue print surface. This is a really quick and easy way to fix something like that. But it wouldn't necessarily solve all of the problems with this keychain. So
did everyone catch that cutting part? Because that's like a really important piece. I feel like I just want to make sure that there's like some yeses in here. Yeah, using that cutting tool and being able to slice off the bottom so it creates a very flat surface, I think is a really important hack, if you will. So Phyllis said no. Don't know if so. What Hannah kind of showed it again. So in our software, there's go back, Hannah, and show the little cut. You can click this cut thing and it'll give you basically a preset cutting tool, if you will. And she just moved it up and down. So it sliced off the bottom of the model.
Drag.
Yeah. Dragged it. Yes. Dragged it down. So it sliced off the bottom of the model. That way the surface of this print is actually sitting on the platform much better.
So when I cut off the bottom, I'm going to click the delete button on my keyboard to get rid of it. And then the new piece that's fixed, I'm just using under the move section, the on platform button to move it back onto the build plate.
Yeah. Thanks, Phyllis. Cool. Yeah, so I think
that's a really useful tool.
Yeah, you'll use that a lot. I mean, if you're doing a lot of design with students, that you're going to use that specific thing a lot because a lot of students will put models below the surface and all that stuff, and you'll have to deal with it.
The other thing I would be looking for is telling the students to like take this soccer ball shape, make it overlap with the bottom a little more. And if you've got weird like jumping things happening like I'm seeing here, you know, you can adjust down here your snap grid to being 0.5 millimeter. Sometimes that's, or 1/4 millimeter. Sometimes a full millimeter is a little bit too detailed or it's too large of an instrument. So the snap grid is a really nice tool. And then I would make this taller so you can actually see that it's a soccer ball shape better.
Hannah, Robert asked, is it better to have students fix the problem or do this slicing trick?
I think that depends on the age of the student. I think if you are working with 4th grade and up, your students can start critiquing each other. There are lots of art standards talking about providing constructive criticism on pieces of art. And this is a type of art. It is a type of engineering, it's a type of design, but it is also art. And having students go in and check each other's models, find things like this, will make it more collaborative, more like a real world, you know, iterative design process where they can actually provide this feedback. You can try that with younger students, but in general, a lot of our K2, K3 design students or designs are very simple because we know students can't necessarily read yet. It's harder for them to follow all the steps. So at that point, as the teacher, I would probably take some of that into my own hands and maybe just explain to them what I did before printing it. So it just depends also on how much time you have. If you don't have time for the students to do a design review before it gets printed, there are plenty of teachers who print failed prints and let the students learn that way. But that does, you know, waste plastic. It does waste printer time. So having the design, you know, critique happen before it gets printed can save a lot of headache and effort.
Yeah. Elizabeth asked, like, when you say overlap at the bottom, Elizabeth, I can answer this one. Do you mean make it more flush with the platform so it doesn't need supports? I mean, rule of thumb is you want whatever you're printing to have as flat of a bottom surface as possible. that will ensure or have a higher likelihood that it prints successfully. So yes, you want it to be flush and flat on the actual platform you're printing on. Now, in the case of that yellow model, you know, and if you're unsure, because the print surface maybe is not super flat on the bottom or whatever it may be, you want to just turn supports on. We usually have them set to just auto add supports if needed. But if you're using, you know, any other printer or any other software, just add the supports if you don't know, just because it will help ensure the success of the print.
One of the other things is if you have student designs like this, where it's really, really thin and you're not sure it's going to print successfully, encouraging your students to just add some of their own like built-in supports to the design can work. So like they could add something like this that, you know, maybe I need to go even more detailed on my snap grid there, just build some support into the inside of the model. So now, you know, I've got something holding it up, and maybe I can find a better shape than this. Maybe I'm looking over here and I see I know there's a white one somewhere. This is like a perfect little cup shape that I could fit in that opening. So there are always different ways that you can tweak and fix models like that. But oftentimes make sure it's not too thin, not too fine detailed, because it does need to be able to support itself. It does need to have some thickness. So something like this might print a little better than the original version we said. I would also probably add you know, a little, just a basic cube under this, you know, stem of the trophy to support it from below, so you didn't have to print it with supports, because it's a little keychain. Like, you just want it to be solid and structural. It's okay if it loses a little detail.
Hannah, do you think, just for the sake of everyone that's here listening, is there a kind of, I know we like to talk rule of thumbs, if there's a rule of thumb as you're building a 3D model, at like what angle is the best where you don't need support as you're building? Like, is a 45-degree angle a good?
45 is the classic. It depends a little bit on your printer. I've noticed higher speed printers like our E4 out there, even a little steeper than that is better. You know, 50 to 55. But with supports, you can do full circles. Like I've got a, you know, globe of Mars here that, you know, this has a full circular bottom, and yes, it has some scratchy-ish surface on the bottom that I can feel. You can't really see necessarily coming through the screen, but you can sand 3D prints. There are liquids that I've never tried that are supposed to, you know, smooth some of these things out. I've never tried those, but, you know, there are ways to make supports work. But either way, like if you can design something to not need supports, all the better.
Yeah.
Oftentimes you can not need a support just by rotating it. You know, if I wanted to print this keychain, I might actually, like, this is a pretty good orientation, or I could move all of these things down to the like bottom edge of it and rotate it vertically so I could get more detail on the soccer ball. Because as Evan and I were discussing lithopanes, trying to find one of my example ones somewhere here, in last month's art section, these have to be printed upright to get the detail. So there it is. You can see there's sort of a picture of a lady here. In order to print these, they have to go upright instead of flat. And so you'll just get more detail if it's upright.
Well, Elizabeth, so yeah, we don't want to get too confusing on this, but Elizabeth, what Hannah is saying is if you're printing things kind of flat, you're not going to have as good of quality in the sense of this keychain, but if you turn it upright, you'll get a little bit better quality on the print. So what Hannah is saying is to move the lettering, the trophy, and the soccer ball down so you can turn it upright, and you don't need a bunch of supports under each of the objects that are being printed. Hopefully that made sense. But once again, it's you know, it's a minor difference. Don't beat yourself up on this type of stuff. It's more just getting the models successfully printed. That's the most important thing. These are tweaks that you can do kind of over time to improve quality and things like that.
Yeah, so let me show you how I would do that. I'm going to group this little support with the trophy first using the group button up here. And again, we show more of these things in the Tinkercad video, so I'm not trying to necessarily demonstrate how to use Tinkercad here because there are lots of tutorials out there. But I would line everything up with the bottom edge, and then after I group it together, I can rotate it to be vertical, and I will show you what those look like in RoboPrint as well. So that is thinking for a second, rotate it 90 degrees, and export it now like this. So actually, you know, I'll leave this original one in here and then bring in the two new versions I have. Repair. Yes, put it on the platform, repair. All right. So now we have option 1, option 2, and option 3 all here. And because these are so small, I will also create a copy of them that is just a little larger, say, you know, 50 across. Whoop. I always do that. And now when I click slice this, you'll be able to see, all right, I have no supports enabled, but I do have a raft that's going to go under the models, and these are just some default things, and we'll get to take a look at what these look like. So down here, it's real rough to see that that was a soccer ball, that that is a trophy. It improves a little bit here by making the soccer ball bigger and the trophy have a little bit of a support, but I'm still not expecting this to print well. That's still too thin. It needs more support under it. This one, again, the trophy is just too thin, but you can now see that there's actually a soccer ball shape to this, which I'm not really getting with this. So this print preview, this slice preview is giving me a lot of good information. And as I look at the larger ones, I can also see in more detail, you know, what I'm getting out of this. So using your slice preview as another troubleshooting step is a really good way to give you an idea of what you're going to print. So again, most slicers have this, RoboPrint does. RoboCloud doesn't as much, but you can even go like layer by layer here to see what you're going to get.
This is also a good way, in my opinion, also to show, like, if you're trying to teach students about supports, and you can like show them the layer by layer, so they see like what the printer is actually going to do, and where the error might come in as it's printing if there isn't supports or anything like that. Adrian, thank you. Adrian put in a YouTube tutorial for, I think it's called Teaching 3D Printing. It's a YouTube channel, it sounds like, for Tinkercad videos. So another resource to check out for sure.
Thank you for sharing that. Yeah. The other thing I wanted to show you about this little lady model here that is very sneaky, but is one of the things I've seen out in the real world, is it's not just that she needs supports. And so far in all of my rotating around, I have not actually shown you her issue. Whoops.
Ah, I see it.
Those legs do not connect to the main body.
Yeah.
And an easier way to spot that, and a good troubleshooting thing in general, is in Tinkercad where it says solid and shows you the color, you can actually turn it transparent. And now I can very clearly see, like, oh, that's going to be an issue there because those legs don't touch. It looks good from the outside. It looks really clean until you actually look closer. So supports would help, but as soon as you remove the supports, the feet would fall off. So that's just another tool in your toolbox there, is to go under the solid shape here, and you can turn things between solid and transparent. So again, have your students check this on themselves, have them check it with each other. If you're working in those print pods, trade and have them evaluate each other's designs and check for things like that.
And once again, reiterate to your students that they need to, I know we didn't go like in every single possible error that could happen with Tinkercad, but reiterate to them they need to be constantly moving their build space around to be able to see it from 3 dimensions, right? There's so much you can lose from just looking at it from one angle, but if they're constantly like moving around and checking it from all different sides and all different angles, they're going to spot things before you spot them as the teacher and fix them, hopefully.
Now, this last model here is by far the trickiest and the one that most intrigued me when I got it from a student, which is, if I just exported this box. If I bring this into RoboPrint and show you what it does when I slice it. Sure, repair the model, why not? And center this, is off to the side, start slicing. Oh, I have the wrong nozzle size here. There we go. Braydon, any ideas what I've done to this cube?
I actually don't know. I haven't personally seen that, so that's interesting. My guess would be something about, is it like hollow or something?
Very good. Yeah, I didn't warn him about this one. So if I ungroup this, I saw this as it was a truck originally. The student had made thin walls and built a completely hollow object that was so thin it didn't actually have any real world thickness. So if you look at my dimensions here in Tinkercad, this is 0.01 millimeters thick.
Interesting.
So that's the kind of thing that I would never notice looking at a design in Tinkercad. The only way I figured it out is because when I tried to slice the student's file, I got this.
Because our nozzle is 0.0 or 0.4, so it can't even go that thin.
Exactly. And so this is unusual, but one possibility certainly is that students sometimes will try to build houses or something, and they aren't thinking about the thickness of individual components. Maybe they were trying to build a box and they were trying to get the shape, and they were just thinking about it as 2D planes shoved together rather than as 3-dimensional solids. So Braydon, I've shown a lot here with some Tinkercad things to look out for and ways you can check with slicing, in the slicing preview of RoboPrint. But what are some of the general things you would do when you set up a design? We've got a question here of, is there an ideal minimum thickness? Do you have any slicer settings you recommend always doing or not doing? What are your thoughts on that?
Yeah. Do you want to answer? I'm going to pull up and maybe throw a model in here, and then I'll kind of jump over.
Yeah, so I'll take the ideal minimum thickness. I would say 2 millimeters is my general minimum. If you're doing something like a lithophane, you can go thinner than that as long as there is enough support around it. But for a lot of designs like keychains and stuff, I do 2 or 3 millimeter bases, and then you can have some more detail like on top of it. But often you don't want to go too much thinner than that.
You can see my screen, right? If I click start slicing, does that pop up or no?
Yep.
Okay, so I'm going to go back to basic mode. So a couple of things, just kind of rule of thumbs. Obviously, this is using our software, but once again, we use similar terminology that other softwares have as well for slicing. But if you have one of our printers, or if you're interested in getting one, this is the one you'll be using if you're using a desktop slicing software. So Hannah kind of showed you, obviously you can move the model around the platform. You can rotate it if you need to rotate it on there. You can obviously click this surface to platform, so it drops it onto the actual platform. If you want to scale it, you can do it just by using these buttons, and it does uniform scaling, or you can click off the uniform scaling and just move one dimension, scale one dimension by itself. Okay. Cutting, you guys already know that. You can duplicate models. So if you want to duplicate this, you can do that. this will kind of auto lay them out so perfectly in kind of the center of the platform, add supports and stuff like that. So I just wanted to talk to you a little bit about that. When you go into slicing, I'm going to click this little start slicing. Now, once again, we've kind of pre-built settings that are sort of like best case scenario or highest probability of your print that you place in the software having success with it. So, but I want to give you a couple of little like tips and tricks of things you can change. One of the things is, this raft, we always enable. Now, when you looked at, and when Hannah was talking about like kind of the slicing and showing the slicing preview, you kind of noticed that purple surface at the bottom, that was a raft. So it's really like a sort of outer flat layer below your 3D model that once again will just help ensure that whatever's sitting on top of it sticks to the platform, that you're not going to have any print issues. Sometimes when you're printing models, this one is not a great example of it, but when you're printing models, it actually, I'll show you this. This might be a good way to actually talk about this. So if I was printing something like this, for example, right? Surface to platform, right? My base, that was actually not a good way of doing it.
If you do surface to platform and then double click on the bottom, it'll line up that bottom edge for you with the platform. So zoom your screen to the bottom there, or look from below.
Yeah.
And then double click on that bottom surface. It'll actually align that surface for you with the build plate.
It might have done that, but I didn't quite see it. Anyways, when you're going to slice this, right? If I have that RAF enabled and I have a small bottom surface, like the RAF will help make the bottom surface a little bit bigger. That way it has a better likelihood of actually sticking to the platform. Okay. So that's just like a little sort of rule of thumb there, is to add a raft if you don't know. We have it auto set to being enabled. If you want to save material, you can turn it off as you become more comfortable with which models will print better and things like that. But that is one area that you can adjust in order to save a little bit of printing material and whatnot. If you want to get into expert mode, this is where you're going to have a ton of different types of settings. Okay. You don't need to go in and like modify, a ton of these different things, but the one that I would say you can modify the most often is your infill percentage of your actual print. Okay. So infill is just another kind of way to say how solid or how hollow do you want a 3D print, right? So, or how dense do you want a 3D print, right? So right now we have it auto set to 15%. So it's going to be 15% dense, the actual model that you're printing. Now, if you want it to be 100% solid, you can do that. Obviously, it's going to not only take a lot longer, but it's going to use a lot more material. If you want it to be a little bit more hollow, you can do, this is fully hollow. You can do it 5%. So it's quite a bit more hollow, and this will use less material and take less time. So I just quickly want to show you this. So if let's do 5% fill density, and I go to slice this model, it's telling me that this model on our E4 3D printer will take 14 minutes at 5% infill. So pretty hollow. But if I close this preview and I go to slice it and I put 100%, so we're going to do totally solid, it's going to take double the time. Okay. So quite a bit longer. Now this is a smaller print. As you get into bigger models, this will be a significant difference. So you can kind of play with the infill percentage to actually, make sure that you're using less material and cutting down on the print time. Right.
The other one I would consider showing, Braydon, if you would, is under general, you can adjust the print speed. So if you're ever having issues with the print not working, your base print speed being 300 millimeters a second, maybe you need to slow that down to 200 or 100. And you can click in the box and type 2 or use the arrows like Braydon's showing. Same with travel speed. So that will adjust your print time, but it is one of the ways, if you're having tricky prints, detailed prints, to increase their odds of success. And if you mess with all these settings, there's always a reset to default button.
Yeah, well, yeah, once again, going from 300 to 200 might add another 10 minutes for a print like this. But once again, as Hannah is mentioning, maybe you want to get more detail and things like that. So slowing it down will help sort of perfect some of the details of the actual print that you're doing. So that's it's another great one to look into and adjust. as you're doing it. You don't need, once again, all these are sort of just preset ones that are built in here. I mean, if you get super duper advanced, you can kind of go in and mess with some of these ones, but I don't recommend it. Main ones is fill density, adjust that. 15% is our default. You can mess with it however you want. You can add supports. You can kind of change the supports if you want. That's another one. Don't want to go too in depth with that, but I typically use linear. Hannah, do you use tree
I
shape?
like linear as well. It's easier to remove. The
Yeah.
important thing with supports, though, is you can't just set them in the slicing settings. You do also have to use the side menu to set them up in advance.
Yeah.
So that, Braden, would you at least show them that button while you are sharing your screen?
Yep, I will. Let me.
I think you have to slice to get out on a Mac.
Yeah, so this one right here.
So this is where you set them up.
So this would be the linear, this would be the tree type. And if you're just wanting to set up, now this one model doesn't need actual, actually, maybe I can just quickly.
Rotate it 10 degrees in some direction to make it an awkward angle.
Yeah, let's do a little rotate here.
Oh, I think you have to unclick surface to platform now. Yeah. There you go.
A weird right here, and then I click supports. I'm doing linear supports, not tree, because linears are easier to remove. And I can click like something like auto supports, and it will add. You can also manually add supports if you want to get in there and get nitty gritty. I don't know, maybe I would on this model in this weird angle, but you don't necessarily need to do that. So clear it, auto supports, and then you can go in and you can slice this model. Okay. Anything else? Anything else anyone wants to know about this type of software or slicing in general?
Yeah, we're going to stick around for questions, but we are right at our, 2 minutes past our 45-minute goal here. So thank you all for joining. Braden, I'm going to steal sharing your screen for just a second to show our email addresses. That way, if anyone has additional questions they want to reach out to us, they can do so. I've also dropped our website in the chat there for anyone wanting to download RoboPrint. Like I said, it is available for free, whether or not you have a Robo printer. It won't slice for your other 3D printers, but it still can be used for troubleshooting if you don't have a Robo brand one. And please join us next month. It'll be Jillian and I back on Wednesday, November 12th at 4 p.m. Eastern, 1 p.m. Pacific time. I am putting the short link here in the chat. It is case sensitive, but that way if you want to go ahead and register now, you can, or you can do this QR code. And we're going to be talking all about career exploration and really just getting your students engaged by thoughts of possibility. There's so much anxiety amongst our youth, especially with things like AI. So inspiring them with real careers, inspiring them with the possibilities of what is out there and how to tie it to what you're teaching is going to be all about what we are discussing. I do also see a question in the chat here of, do you have videos on changing colors on OnePrint? We do. That is in our MimioSTEM YouTube, but just real quick here, under the export setting, if you go to others, we have a pause at layers, and you can choose whatever layer you would like it to pause at. You can do multiple layers, and that will automatically pause at those layers to allow you to change. Now, our printers are all single extruder. That way it's simple, it's straightforward, it prints consistently, no extra headaches, but I can then come in here and look at what layers I'm telling it to pause at. So I'm going to pause at layer 10. Perhaps not the most sensible layer for those big keychains, but
yeah. Phyllis, this is a great one. So I'm glad you asked. That is a phenomenal question. We get that quite a bit from teachers. Like, I want to change colors mid-print. If you do what Hannah is doing right here and change the layers and kind of adjust and find out like, oh, at layer 20, I want to change, then you can create those pauses that she just said in there. And then you can change the material out, put a new material in, and like continue the print. It'll pause when it's done for the next color change as well.
And I am going to drop a link to that specific YouTube in the chat right now, because we did just make a video on that not too long ago. So this video here, it's on our Robo how-to playlist, is how to automatically pause for color changes mid-print. And it's about a 3-minute video that shows you all the different steps in the process.
Yeah, if you haven't checked out our MimioSTEM YouTube, check it out. There's lots of cool videos about using this software, the printer, all this stuff. So we have lots of fun resources on there as well for educators that are using our printer. We only work with schools. We only work with teachers. So, you know, we're always building content and helping teachers figure out how to use products like 3D printers successfully within the classroom. So please reach out to us. Hannah put our contact information in there as well. So if you have any questions about the products, the printers, Tinkercad, feel free to reach out to us. Happy to help you. Thank you, everyone. We appreciate you. Thanks for joining. Hopefully you enjoyed these and lots more to come over the next couple months.
See y'all.
Bye.